Happy Thursday, guys. Happy Thursday again. So our warm up, let me see some of your responses. Oh my gosh. What happened? Technical difficulties, right? I want to see some of your responses. And it froze. How does that work for assignments? Like if it's due at 11:59, all the times that I put on Schoology, it's Pacific time. So if it says 12 midnight for me, that would be 2 a.m. for Jalisco and Texas, right? And so, yeah, it'll adjust. And if you're in the UK, it'll be at 7 a.m. Yeah, so all the times I put in there. That's a good question. Okay. I'm sorry, my Desmos froze. So I'm trying to look at your answers and it's frozen. But looking at the picture, right? There's the picture you saw, and I just asked you, what do you notice? What do you wonder? Right. Yeah, that's Mario. For those of you that didn't know, that is Mario from Super Mario fame. Oh my gosh, I can't read your responses because I am stuck. Technology, right, guys? Well, if you want to tell me in the chat, maybe what you put in the warm up, or if something you're wondering now, look at that picture. What comes to your mind? What do you see? What do you notice? What do you wonder? Let me know in the chat because I can't get your answers from Desmos because it is frozen. It will not refresh, and I can't see any of your responses. Nothing's coming up. Come on. Nobody wants to tell me in the chat? No, Mr. Suffer. That's your fault. Your computer's lagging. Can you guys hear me? Am I laggy? A little. You can hear me, but I'm a little laggy. Okay, I think it's that's what's happening. My internet is acting dumb. All right, let's see if I can get on my phone. Hold on. Let's see if I can do it this way. You can hear me perfect. Yeah, I think the sound is good, but I don't know. Is the video kind of laggy? Okay, let me close a few windows. Maybe that's... All right, let me see if I can do it here. I'm going to do it on my phone. Because no one's putting it in the chat. Why can't I look at... There we go. Okay, now I can see it. So here is what I see. Oh, thank you. I got one in the chat. Mario is not only being mirrored throughout all coordinate planes, and Mario is also being rotated at 90 degrees each time. Ah. So is it a real mirror? So I heard mirror and I heard rotating, and then I heard 90 degrees. All right. It's rotating, and I wonder how many degrees is the rotation, someone said. I noticed the same picture, but flipped in a different direction every time. Mario is on all sides, but is facing differently in each one. He is being rotated. Okay. What I notice is that there are in every direction. I wonder why there are 4. I noticed about the image that it's Mario, good, and that every quadrant on the graph is different, but they contain rotation, translation, reflection, and diagonals. Okay, I noticed the Marios can form a triangle or a rectangle. Okay, like if I connected them, kind of like you're saying, I could, if I connected all four, I'd have a square or a rectangle. If I, oh come on, if I connected three, I'd make a triangle. Okay, I see that. Okay, I like that. I noticed that the picture has Mario's going in the direction the quadrant it goes. I wonder if I'm right about the order it goes in. The image stays the same and it's turned slightly each time it is rotated and reflected. So this person thinks it's rotated or reflected. So that's a good question. Is this image being rotated or reflected? And what would be the difference? I notice it looks like Mario is running on the walls. Yeah, it does, right? And I wonder what kind of geometry this is. The image is mirrored on all sides, which we haven't seen yet. So again, mirrored, right? And that's what we talked about before, mirrored. That means it would be reflected. It's going in a circle. Okay, I like that. I notice that the picture is rotating. I wonder how we will rotate the image. The image each face a certain direction and look like they are rotating as they move along. Mario seems to be rotating all over the graph, and I wonder if Mario can actually make a shape or he's already a shape. I notice he is reflected over almost every side, and I wonder if he is hungry. Okay. Yeah, all that movement, right, gets you hungry. I notice that there are Marios that are rotating around a certain area on the graph. Mario is spinning. Ooh, that's another word, spinning. I like that. What I noticed about the picture is that it is rotated on all four sections of the graph. I wonder, though, how it was able to do that. It keeps rotating by 90 degrees in each photo, whether it is clockwise or counterclockwise. I notice that there are four Marios at different angles. I wonder why they are there. I notice the Marios are going counterclockwise. Ooh. Hold on. Where? Oh, I can't hear anything. Let's do that again. Counterclockwise. What is that? One is backward, one is sideways, and two are angled. I wonder which one is the reflecting to which one. It has rotated around the whole graph, and I wonder how they rotated it, because it's not a shape. It is a shape, right? Is he not a shape? He's not a basic shape like a circle, or he contains many shapes, but he has a shape, right? Right? That's his shape. That shape doesn't have a name. Well, I guess that shape does have a name. His name is Mario. Right? And if I just showed you that shape, you would recognize it, I think, maybe. Okay. I noticed it's the same shape, and she put shape in quotes, but in different ways, rotated differently. I wonder why it's not an actual shape, but Mario, LOL. Because, okay, because he's fun. We love Mario. I think we all can say we all love Mario, right? We all, even in my childhood, I had Mario, and then in your childhood, you had Mario. He's affected all of our childhoods. That's kind of crazy. And you're still playing games with, well, some of you are still playing games with Mario, right? Especially if you have a Nintendo Switch. The warm-up, Mario is not only being mirrored through all coordinates, but Mario is also being rotated 90 degrees each time. Super Mario Galaxy, yeah, exactly, right? So, okay, so here's what I'm going to do. Give me 1 second. Okay, let me get this, because I want to show you, because we heard a lot from these answers, and none of these answers are wrong. Don't you love these warm-ups where the answers, like any answer you give is correct? Just because, as long as you give a reason for your answer, like these warm-ups, they're nice, right? Because like you're not wrong. You're not wrong. So let's see. I want to cut out a Mario and show you on camera. Let's talk about rotation and reflection, because we keep hearing that rotation, mirrored. What was that other word? Spinning, I think that they said. Going in a circle, someone said. Yes, Mario was spinning, right? So what is it? Is he being rotated? Is he spinning? right? Is he a shape? Can we find a point on Mario and figure out like what's going on with this? We'll try to do all that stuff. But let me print. I want to print out this Mario because I want to show you on the camera. Let's rotate and let's spin. So downloads. Where's my Mario? Where's my Mario? There he is. Yeah, my computer's super slow. Oh, what's going on? I have so much RAM in here. It shouldn't be this slow. There we go. So let's print him out. File, print. That's too big. Let's scale. Come on. Okay, let's do that. All right, so I'm going to print him out, and then we're going to go on the camera. We're going to check this out on the camera. And then we're going to look at, okay, what does rotate mean? What does reflect mean? And which one? What's happening here? Is he doing both? All right, here it comes. I'm going to need scissors too. All right, so I printed out Mario. Let me cut him out. I'm not gonna cut him out perfectly. Just gonna cut around him. Just so you can see what I'm talking about. Okay, so here's Mario. Okay, here's Mario. So, what does it mean to rotate? So if I have him here, and if I'm going to, well, first, what does it mean to mirror? If I'm going to mirror him, let's see, can I make this go higher? Yes, I can. So here he is. If I mirror him over the pen, so if I'm going to mirror him, remember, if we're going to mirror something, we're going to reflect it, right? And we need a line to reflect it over, okay? So let's say we're reflecting it over my Apple Pencil. So if I reflect it, it's a flip, and he flips over and he faces the other way. Mister, I can't see. So he's basically facing the other direction. I don't know if you can see that. So if he's facing the other direction, right, his face is the opposite side, his arm is on the opposite side. Is that what we have right here? Do we have him facing the other way, or is it? Let's look at the arm that's facing up, right? Let's look at the arm that's going up. It would be on the other side, wouldn't it? If I did a reflection. If I did a reflection, he would be over here. It would be on the other side. Okay, is that what we're seeing in the picture? I don't think so. It looks like he's facing the same direction. So let's think about this then. If I'm rotating him. So Mario's like this in the bottom corner, and then if we rotate him this way, does that look like the other corner? And then we rotate him this way. Then we rotate him this way. And so we're kind of rotating around a center, right? We're kind of rotating around a center. Like imagine there's a center here, and I put a string. Do I have string around here? I should have some string. I have a cord. How about this? How about a cord? So it's kind of like I'm getting the center. So I'm putting a center, and I'm putting the cord there. And then I'm putting a cord on him. And then I'm just doing this. I'm like rotating him around a center. If I made it smaller. I'm rotating him around a center, right? It has the same length. So I'm kind of doing that. Do you notice that? Do you guys see that in the picture? And then I rotate this way. Then I rotate this way. Then I rotate this way. Now, someone said something about 90 degrees. What do you mean by 90 degrees? What's a full rotation? I think some of you were talking about kick flips and all that before, right, a few weeks ago. And I think you know these degrees. A full rotation, if I went from this guy and then I went all the way around and I went back to this guy, how many degrees is that? So if I started here and I went all the way around back to this guy, that's how many degrees? It's 360, right? 360. Right? 360 is a full rotation, is a full circle. So that means if I go halfway, what's half of 360? 180, right? If I just turn halfway, like if I do this and I turn, this is 180. Right? I turned 180 and then now I'm back, so now it's 360. So full is 360. Half is 180. Well, what's half of that half? What if I only go from here to here? What's half of 180? 90. So yeah, so this is 90 degrees. So if you think about it, isn't that a 90-degree angle right here? And isn't that a 90-degree angle? Don't we say the x and y axis are perpendicular? So that means this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees, and 90 times 4, well, 9 times 4, it's 36, and then add the 0, it's 360. So yeah, we are rotating. We are rotating, and I think everyone saw that. Good job, good job. Give yourself a hand. Okay, so why Mario? Some of you are asking, we're wondering, why Mario? Why not? It's always fun to start with Mario, right? Let's try to start with Mario. Yeah, I could, I was thinking I was gonna put Bernie here, but I think that's old now, right? I think I was gonna put Bernie here and rotate him. It would have been a little funny, but some of I know you youngsters are like, oh, that's like 2 weeks old, mister. Get with the times. That's not funny anymore. I don't know, whatever. But Mario is classic, so I put something classic. So that's why Mario. And is he a shape? Well, let's look. He is a shape, and can we find a point on him? Can we find a point on Mario? I don't know. I've been looking at his thumb. Like if we looked at his thumb right here, what point is that? So let's see if we can figure some things out. The clapping started. I'm sorry. I'm sorry. Look, I can't help if the crowd is cheering. So let's look at his thumb. Is there a coordinates to his thumb? Can you tell me what the coordinates of his thumb are right there? Anybody?
Bueller.
Close. Someone said 5, -2. If we look here, is it 5, -2? Well, let's look. It goes to 4, -2. Close. It's 4, -2, right? Maybe it's a little blurry. Perfect. So that's 4, -2. All right, let's look at the next Mario. So we all agree that to go from this Mario to this Mario, we went 90 degrees. And someone did mention this. What direction are we going? Because there's a direction. I could go this way. Why not? Why can't I go that way, mister? What is that direction that I just shown right here? Where that arrow is going what? It's going counterclockwise. Counterclockwise. If you don't know what counterclockwise is, just look at a clock and remember which direction a clock goes. Which direction does a clock go? Right? So if I think of a clock, those old-fashioned clocks, right? One of those, the clock goes this way. So that would be clockwise. This would be the opposite direction, which goes counterclockwise. So that's going to be important to what we're doing today. So now let's look at his thumb again. So now his thumb is here. Same point, but now his thumb is here. Now what's the coordinates of that point? What's the coordinates of his thumb now? 2, 4. Okay. Looks very similar to those, doesn't it? It was 4, -2. Now it's 2, 4. Okay. Now what if we rotate another 90 degrees for a total of 180-degree rotation? So what if we go over here? Let's look at his thumb again. Let's look at that thumb again. It's right here. What's the coordinates of his thumb now? -4, 2. Ah. Okay. And then if we rotate again, if we go over here for a total of 90, 90, 90, what's 90, 90, and 90? 270. Yes, so a total of 270 degrees. Now let's look at his thumb. His thumb is right here. And what are the coordinates of his thumb? -2, -4. Ah, what do you notice? What do you notice? His thumb started off at 4, -2. Then I rotated counterclockwise 90 degrees and it became 2, 4. Then I rotated another 90 degrees for a total of 180 and it became -4, 2. Then I rotated again, I got -2, -4. It's the same numbers, aren't they? But sometimes they're flipped and sometimes they're different signs. So that must mean something, right? That must mean something. Do you guys see that? You guys see what he did? Mario? So first, let's look at some key things we talked about. We talked about what counterclockwise is. Counterclockwise is just the opposite direction of one of those old-fashioned clocks. Okay. We established that from this quadrant, and you guys know these are called quadrants, right? That's a quadrant, that's a quadrant, that's a quadrant, that's a quadrant. So we can call those quadrants. And to go from one quadrant, to rotate from one quadrant to the other quadrant is 90 degrees. And then 180. And then if I go 3 quadrants, that's 270. And if I go all 4 quadrants back to the original, that's 360. So we know 360 is all around. Then we can go by 90, 180, 270, 360. And then we also notice, we just picked a point. We picked his thumb. We could have picked any point and we would have noticed the same thing happened, I think. But his thumb, 4, -2, turned into 2, +2, +4, turned into -4, +2, turned into -2, -4, back to 4, -2. So there is a pattern here, guys, and that's exactly, so somebody was wondering in the warm-up, I wonder how we rotate this. How are we going to do this for regular shapes? Well, looking at that pattern happens every time, and if we just remember that pattern and use that pattern, don't have to memorize, right? It'll be in your notes, but if we understand that pattern, we can rotate anything. We can rotate anything. Any questions? Any questions? So, yes, we're going to start new notes. Yes, we have a new note packet. Yes, we have a new note packet. Let me show you how to get there. So again, we go to Schoology. Step 1, go to Schoology. Step 2, go to our course, period 11. Bam. Then if you look here, week 5, we are in week 5. How do you know we're week 5? Because it says February 8th to 12th, and today is the 11th. Today's the 11th. So we click on that. And we go in here and we see reflections notes. Reflections homework will be put in there. I know it says it's due. Again, don't freak out. It says due Thursday, February 11th. Notes are never due. You don't have to turn in notes. The reason it says due is because I had to make notes and assignment so you can use Kami. If you are in Google Chrome, and for some reason it doesn't work on my iPad, this is my iPad. When you click on Rotations Notes, you'll see the PDF here. And if you're in Google Chrome, next to View right here, next to View, you should see Open with Kami. So some of you, those people that use Kami to take your notes and save it in your Google Drive, you can open with Kami and you can write on the notes. Okay, you'll be able to open this and see the whole packet. It's only 3 pages, 3 pages of our examples. Okay. Otherwise, you can just open it up. Some of you, that's one way people do it. Second way, some people print it out. Some people get to this and they print it out in their printer and they take notes that way. Some of you, I've heard, have offered to print them out for friends, which is very nice. I know some of you that do have printers. You're like, I print them out for my friend. I go over his house. I put in his mailbox. I go back to my car. They come out. I'm in my car. We say, hey, what's up? We haven't seen you in a while. And you know, social distance, say hi, and it's good to see people. And I do a nice favor for my friend. One kid in another class, he prints it out for like 4 different friends. And it's double nice because his friends get to get the notes on paper, which they like, and he gets to see all his friends. They get to see each other, you know, social distance, but at least they get to see each other and maybe have a conversation from the yard to the car. And it's really nice to hear that. So bringing people together, helping each other out. I really like hearing that. That's awesome. Some of you are like, yeah, mister, I don't have a friend who has a printer and I don't have a printer. So what do I do? Get your handy dandy notebook. Get your handy dandy notebook, right? And then just take your notes as we go through them. Just copy it in here. Some people like to copy as we're going along and then later on look at the videos to copy the other pictures and stuff, the rest of it. Some people just like watching and not copying anything down and then copying it later, watching the video. However you do it, as long as you get your notes somehow in a notebook, printed it out, or doing it on Cami. Okay. All right, everyone good? Everyone good? Okay, so tomorrow we're going to start talking about and filling out these notes. So you're going to have tonight to fix up your notes, print them out, or some people also, and I know there's not very many, some people actually copy the notes, like this part right here that you see on screen. They copy this with the blanks in their notebook, so that way later on when we go over it, all they have to do is fill in the blanks. It's kind of like they're printing it out, but with their hands. So tomorrow we're going to talk about what are the rules for a 90 degree, 180 degree, and 270 degree counterclockwise rotation. What do we do to the points? And if you looked at Mario, we kind of figured that out today, didn't we? Something happens to the X and Y of each point. They kind of stay the same, but they switch, or they turn to the opposite sign, or both. So we'll talk about what pattern that is. And once you learn the pattern and once you understand the pattern, rotating is going to be a piece of cake. Okay, so we will start that tomorrow. So get your notes ready, however you do it. Cami, print them out. Handy dandy notebook. Oh, wait. Handy dandy notebook. Right? So whatever you do, get it ready. We'll start these actual notes tomorrow. And are there any questions? Yeah, I've always wanted to do a class where the whole class is like a Blue's Clues, right? And we're looking for clues the whole class. You just ordered one of those notebooks. Yeah, how much was it for you? This shouldn't be more than $1. I know like back to school sales are like 70 cents sometimes, but this shouldn't be more than $1. If you paid like $4 or $5 they ripped you off, but sometimes that's the only choice you have. $4 or $5. Ooh, ouch. I'm sorry for that. Yeah, I got this one for 70 cents actually. I got a whole stack of them. And I remember I handed them out. I just had them in class and then I handed them out to people who needed them. So, $4 or $5. Yeah, sometimes you can't find them for that cheap price. Yeah, what I like to do when they're like 70 cents or 50 cents on those back to school sales, I like to stock up and get a whole bunch because then you just never know. Like you get 10, you could have got like 5 or 6 of them for that price. But it's okay. It's okay, I guess, for now. I'm sorry. If I could have handed them out to you guys, I would have. I would have. All right, so if there are no questions, we will start rotations tomorrow. Get your notes ready so we can start doing this tomorrow. And I think some of you have already figured out how we're going to do this by looking at Mario. And, oh, you got 5 for $4.85? Do I have any extras of the older Simpsons Pops? No, I don't. The only one I have left is Homer. Right, Homer's the last one I have, right there. Yeah, I had 2 Marges, 2 Homers, 2 Barts, and I sold them all a couple years ago. I actually should have saved them because they're actually worth more. I think I sold them for like $200-$300 each, which was good at the time, but I think they're going for like $5. I never had Krusty though. Never had Krusty. Yeah, okay, so 97 cents each. That's not good. That's not bad at all. That's really good. So you got 5 of them. So maybe if someone wants to buy one off you, they can leave $1. You can leave it in your mailbox, and then they can pick it up and put the $1 in your mailbox, and then you guys can say hi from the car and the. All right, so if there are no questions.